All right, examples 5 and 6 are going to involve, or examples 6 and 7, sorry, involve simplifying power expressions for now. Again, they're going to get uglier as the year goes on. For now, what we're going to see is we're going to see letters that are being multiplied together. We've already seen that rule. We add the powers, and most of you guys are handling that fine. I think most mistakes there are carelessness as opposed to not knowing how to do them. Okay, today negative powers are going to be involved, maybe even zero powers, so move them where they belong. And then change zero power objects to one, remove if allowed. And that if allowed thing comes back to the whole idea. Is it being multiplied or is it being added or subtracted? For these problems, typically it's going to be multiplied. In examples 8 and 9, there might be some addition to subtraction of 1. So you might kind of look at the structure of those things. Now, look at what it says right here in bold print. I'm going to say it out loud. Everybody has on this yellow sheet of paper. I'm not going to feel the least bit sorry for you if you don't do this on an assignment. You lose points. On a test, you lose points. No matter what the book tells you to do, when it says simplify, and it's this kind of problem here, I want one of each letter raised to a positive power. If the book says to write the answer so that everything's in the denominator, give me one of each letter raised to a positive power. If it says write the answer with all negative powers, write the answer with all positive powers, because simplify means one of each letter raised to a positive power. If you're copying your answer out of the back of the book, and the back of the book has negative powers, modify it so it has positive powers, so at least while you're cheating on your homework, you're at least giving me an answer of the type I like to see. You'll miss it on a test, you'll start losing your 7 points every time, and eventually you'll quit cheating on your homework. But I'm not going to stress over that myself. But again, do not give me negative powers in the final answer. My math teacher drove that point home with me on a daily basis when I was in high school. And it's ingrained in me, and this book doesn't agree with my math teacher or me, so therefore I'm going to win because I'm the one grading your paper. So, there you go. I think I said that forcefully enough that everybody understands that I mean it. Alright, so, look at this problem. Simplify x to the fourth, m squared, x to the negative second, m to the negative fifth. Now, rule 1, or the first step of this process, is letters of the same type you multiply by adding powers. You're adding algebraically, so if the signs are the same, you add, signs different, subtract. So looking at the x's here, x, 4 plus negative 2 makes positive 2. Looking at the m's, m squared m to the negative fifth, 2 plus negative 5 makes negative 3. In both cases I subtracted because the signs were different. In the x situation 4 is bigger, so it's positive. The m situation 5 is bigger, so it's negative. That's job 1. Job 2, if there's any negative powers, fix it. You fix it because if it's on the top, currently this is written as a fraction over 1. If you have no fraction, it's officially over 1 in fraction world. A negative power simply means the object to the negative power belongs on the bottom. Or if it's on the bottom, it belongs on the top. So x squared is perfectly fine where it's at. M cubed belongs on the bottom. It said simplify. I've got 1x, 1m, so one of each letter. Powers are positive. I'm done. Okay, so that's what I'm looking for. And again, that's just following that process. There were no zero powers in this one, so we can just ignore that step 3. Zero powers do show up. We'll handle that when it happens.